in section 3.5 and 3.6, graphing rational functions. And these few questions in the middle of the assignment want you to graph the functions using transformations. So we really do need to do that. So here we have the graph of 1 over x squared, and it is the reciprocal of x squared function. And it is transformed here in k of x. And as you can see, it is the graph of 1 over x squared shifted down 3 units. So let's first talk about the asymptotes for the parent function 1 over x squared. As you can see, for a vertical asymptote, we set the denominator equal to 0. So that would definitely be when x is 0. So we grab that vertical asymptote, and x equal to 0 is its, and I'll turn it off there. X equal to 0 is its vertical asymptote. The horizontal asymptote, the degree of the numerator is 0 and the degree of the denominator is 2. So we know that y equals 0 is the horizontal asymptote. Turn that off. Okay, shifting this function, 1 over x squared, down 3, does not change the vertical asymptote. However, it does shift the horizontal asymptote down 3. So we're going to go grab it, and we're going to go down 3. Whoops, it's right there. And then we're going to get an eraser and erase this one. And click that to turn that off. Okay, so now we need at least 2 points on each side of the vertical asymptotes. So let's let x equal to 2 and maybe 4. How about that? And you could let x equal to 6 if you want, but we'll just let x equal to 2 and 4. So we're going to go over to the calculator, and we talked about how to store a value and then evaluate that function quite quickly. So 1 over x squared minus 3. So as you can see, that is what y1 is equal to. So we're going to quit, and now we're going to store. Remember, we said we're going to let x equal to 2 to store as x. And actually, I didn't have to put that under y equals. I was going to show you another way, but let's just go ahead and do this. So this is alpha y equal 1 divided by x squared. And we will just leave that in there so that we can actually look at the graph when we're finished. So now x is 2, and it's going to plug it into our function, and we have negative 11/4. So we'll go ahead and plot a point, and we said when x was 2, and then, whoops, I better put just a 2 there. And then my y value is a negative 11/4. And we'll plot that point. Now let's go ahead and let x equal 4. So we'll put a 4 in there. We're going to go back to our calculator, and we're going to put 4 store as x. And now we're going to press enter. And now we'll go get this function again and press enter. And now our calculator will put 4 in that function. So now we have to have negative 47/16. I also wanted to show you can put the negative on the outside if you want, and then go ahead and type in your fraction 47/16. Plot that point. Okay, so we need 2 on this side. Let's go for negative 4 and negative 6. So go back here, negative 4, store as x, and we'll go back and grab that expression, and that is negative 47/16. So we had a negative 4, and then we have a negative 47/16. And we'll plot that point. Now remember, we need one more. Let's go with negative 8. So negative 8, and we're going to put the y value in there. So we're going to go back to our calculator, the opposite of 8, store as x, and we'll go back up and get that expression, and we can see that's negative 191/16. 64. So the opposite of 191 over 64. And we'll plot that point. Okay, we should be able to go ahead and click to graph the function. And there it is. It is 1 over x squared, which used to be right up here, shifted down 3 units. And checking that, you can see that that was correct.